Those problems we had with Friday with on the surface area using the net, that was a lot of work. I mean, to find the area of each one, well, first you have to look at the net and make sure you had the dimensions right. And when I did those homework problems, like 8 and especially 10, you just see me checking and making sure I had the numbers all matched up. It was hard. And that's how we did surface area Friday. You found the area of each individual face and then added them up. Now, I have had some students who are really visual learners, and that's the way they have to do it. But there is another way. The other way, we can also use surface area, find it using some formulas that we've been given. All of those are on the back of your formula sheet, say Chapter 10 at the top. And the first one we're going to look at is the surface area of a rectangular prism, like a Kleenex box. A rectangular prism. Just like this Kleenex box. Right, if we look at this rectangular prism, or this Kleenex box is a nice representation. If I look at this face that's towards you, and then I switch this one, which is opposite, those two faces are what? Are they congruent or not congruent? Congruent, which means their areas would be the same. So could I just find the area of one of them and then multiply by 2, double it to get the area of both together? How about that? And that's the surface area formula for a cube. You find the area of each individual face and then double it. Now, wait a second. You don't have to write this down. It's on your formula sheet. Right? It's right in front of you. However, you might want to modify that. We know that from the last chapter when we were factoring. What can we factor out of this expression? The 2. So we could rewrite this as what? 2 times area of A, B, and C. Add those 3 up and then double it. That's what I like to do because that saves me some computation. I'm only doubling once then. I can add up the 3 areas individually and then double it at the end. It saves me a little bit of work. Yeah, it'll work. I just factored the 2 out. Area of A, area B, and area C. All 3 areas, added them together, and then double it. We'll see it here in a second. Yes, ma'am. Nope, you do not have to multiply by 6. You just double it. I'll show you both ways. I'll prove it to you. Okay, so Jordan's a non-believer right now, and I'm going to prove it to her. Okay, area of A. Well, what are our dimensions for this rectangle A? Well, this is 4, right? And that dimension is 10. So the area of rectangle A is 40. If we were following the strict formula, it'd be 2 times 40 then, which would give me 80. What's the area of B? So rectangle B is here. 10 times 6, 10 by 6, so it's 60. 2 times 60 would give me 120. All right, and C, which is over here, right here, right, 24. And 2 times 24 would give me 48. Now the way I like to do it is I just add up my 3 individual areas. 40 and 60 is 100 plus 24 is 124. Then I double that to get 248. Now if I add these 3 up, what do I get? 80, and that's 200 plus 48 is 248. So we can easily see we get the same answer either way. We get 248. Yeah. Yes, so do I. You're only doubling it once then. 2 B, this length here is 10. This is 6 right there. 10 times 6 is 60. Yes, ma'am. Yes, sir. I'm not. Okay, come on up and show me. Come on up to the board. Oh, here, I just doubled each face individually. And that because Jordan said, well, wouldn't we have to multiply by 6 instead of 2? So I showed her whether I double each face, the area of each face individually, or add them and then double at the end. I still get the same answer. All right, that's surface area of a prism. You can do it either way. You can find the individual face, then double that one, or find the faces, add them up, and double at the end. That's up to you. You're going to get the same amount either way. For a pyramid, how would we do a pyramid? Well, here's an example of a pyramid, and I was told that this is wrong. Should be 756 feet long. Okay, so this is the Great Pyramid of Giza in Egypt. Says the square base here is 756 feet long. So all the way around. So it's 756. Then we have this triangle here, which I'll do in red. And it says the slant height here is 612 feet. Well, let's take a look. If just that shape, what shape is that? Well, that's a triangle, right? So 612, we would call that what in a triangle? Not the slant height, but just the regular height. Yeah, just the regular height. How do you find the area of a triangle? Base times height divided by 2. So I put that. So I need that 612 and I need that 756 to find the area of this triangle. Well, what do we know about all the triangles on that pyramid? They're all the what? They're all the same. So I could find the area, they're congruent, right. If I could find the area of one of them and do what? Why 4? 4 sides because it's a square pyramid, right? If it were a triangular pyramid, what would I be multiplying by? 3, because there's only 3 triangular faces. And then I'd have to set. Now, in this problem, we're assuming that we're including the base as the surface area also. We're just assuming we're including that square, even though it's on the ground. So to find the area of this one, it's 4 times the area of the triangle, since there are 4, plus the area of the square base. Could also, this bottom one could be a triangle. If this were a pentagon, if this were a pentagonal pyramid, what number would be here? But not 4, but 5. And we'd have to find the area of pentagon, which we don't have a formula for. We're not going to worry about it. We'd have to cut it into if it's a pentagon, we have to cut it in, if it's a regular, into a trapezoid and a square. So we're not going to get that involved. So to do this one, we have 4 times the area of the triangle. The triangle is base of 756 times the height of 612 divided by 2. What's the shortcut here? And that becomes 2, right? It cancels. 4 divided by 2 is 2. So we can just do 756 times 12 times 2. And then to that we're going to add 756 squared. Why is it 756 squared? What's the area of a square? Length times width. And then, but what is it about a square? The length and the width are the same, so any number times itself is squared, right? Okay, well this is a little bit of figuring I'm going to do, so let me get my calculator. So 756 times 612 equals times 2 gives me 925,344. No, 9 million. Area of a triangle, base times height. We're going to add the areas at the end. So it gives me 925,344. 925,344. The calculator goes away as soon as I start to write. So that's that area plus 756 squared, which is 571,536. 571,536. Many times. The question is not have I, it's how many times. So I'll add those two together now. And I get one. Okay, go ahead. 1 million. 1,496,880 square feet. Well, that'd be a lot of paint if you had to paint that, wouldn't it? I don't know, how many acres would that be? An acre is how many square feet? I don't know, a square mile would be 5,280 times 5,280, so 25,000 square miles, approximately 26,000 square feet. So divide that by 26,000, and it'll tell you how many square miles that is. Wasn't quite that tall. 26,000. So 57.5 square miles. That's assuming the bottom, though, too. I mean, not just the triangular faces. All right, now the next two we have formulas for that are on there. The surface area of a cylinder and a cone. Now let's look at the surface area of a cylinder formula. I'm going to break it down for you. This second part right here. Pi r squared is what? Area of a circle, right? Why is there a 2 in front of it? There's 2 circles in a cylinder, right? When we're looking at surface area, each end has a circle. This is also on your formula sheet, this formula, like all of them. Then, if you look at this part, h would be the height of the cylinder. Right there. What's 2 pi r? The circumference of a circle. 2 pi r is the formula for circumference of a circle. And on any cylinder, that's what the width of the cylinder is. In this lateral side, the part that bends around the can, the part of the can that you grab, that, when it's flat, it's a rectangle. And you have the height, well, the width of that rectangle is 2 pi r. It's the circumference of the circle around the top. So that's where that comes from. So we can pretty quickly find the area, or surface area, of this cylinder. And then we'll go back and get all that work from the last lesson. I'll show you how much faster it is. All right, we have a radius of 10 and we have a height of 25. Do we need any other numbers than that? No, those are the only 2 numbers we need to go in here. 2 times pi times the radius of 10 times the height or length of 25. That'll give us the surface area of the side of the cylinder. Then the surface area of the 2 circles, 2 times pi times 10 squared. Well, 10 squared is 100, times pi is 314, times 2 is 628 on this one. Here we have 25 times 10 is 250, times 2 is 500, 500 times 3.14, 1570. Okay, thanks. 1,570. Just add them together. So that'd be 2198. 2,198 square centimeters. Now, does that look easier than what we did right there? Here's what we did before. Here's what we did with that other problem. And that's not all there. It didn't copy all. Yeah. That's all right. I'll finish drawing it in. Here's our one circle here. We had our other circle there. And what it came from in the last lesson was this cylinder here. Here is that problem. Well, how much faster could we figure that out right now? Well, we'd have to take this and get 5.55 to turn it into a radius. Remember how many steps it took last time? Now with this formula, it's 2 times pi times 5.55 times 23.5 plus 2 times pi times 5.55 squared. Write that out. Take you less than a minute. Do all the calculations now. What did it take me last time? Like 3 minutes? 4 minutes? Times that. Yeah, these are all multiplied. These are all multiplied and squared, and then you add them together. Because what you're finding them separately. You're finding the area, surface area of the side, and then you add to it the surface area of the two circles. No, it's not going to be the same thing.
Where'd you get 1570 from?
2 times pi times 10 times 25. 25 times 10 is 250. 250 times 2 is 500. 500 times 3.14 is... You're not getting that? Okay. Did we make a mistake? 2 times 3.14 times 10 times 25. 1,570. Yeah. What are you getting? Did you get it? Yeah. Okay. Here's the last one. This is a surface area of a cone. Now notice, you only need two numbers. One of them is kind of different. Something different. It's called a slant height. It's the height of the cone on the outside. We don't need the height on the inside. But once again, just like the cylinder one, surface area of a cone, all we need are two numbers. The radius of the circle on the base and the slant height. So pi times the radius of 10 times 30 plus pi times 30 squared, or 10 squared. 10 squared. So 10 squared is 100 times pi is 314 plus 30 times 10 is 300 times 3.14 is 942. Add those two together. 1,256 square centimeters. 1,256. Plugging my two numbers into the formula and go. 434 and 435, 1 to 19. You'll be burning up your calculators today.